Before we close, let's run through and summarize our learnings. Now, we have gone through one-way and two-way ANOVA both. So what is the difference between both one-way and two-way ANOVA? So one-way ANOVA, we used to compare the means of factor levels for one factor, like studying the response time of an ambulance in various cities. So in this case, city was the only factor. We use two-way ANOVA to compare the means of factor levels of two factors, like studying the response time of the ambulance service managed by multiple agencies in different cities. So here we have got two factors, city and the agency. We had learnt about the assumptions in case of one-way ANOVA. So would the assumptions of one-way ANOVA apply to two-way ANOVA also? Definitely. Two-way ANOVA also requires the design to be balanced. So all the subgroups must have the same sample size. It also assumes that the observations should be independent. There should be homogeneity in variances, and also in each subgroup the data should be normal. And as was the case in one-way ANOVA, here also it will hold good with nearly normal distributions. What would be the key inferences to draw while interpreting the two-way ANOVA? First and foremost, one needs to check the p-value for both factors. If it's less than 5%, which is the level of significance we choose normally, then we reject the null hypothesis that sample means are similar. So it means we have enough statistical evidence to believe that the sample means are statistically different for the factor being studied. Next, we check the confidence intervals. So if the intervals overlap, then the inference is that there is not enough statistical evidence that the means are statistically different. So is it advisable to follow up two-way ANOVA also with ANOME or analysis of means? Yes. As we had seen earlier, ANOME helps to determine the best performing factor level. Now, interpretation in case of ANOME with two factors is different as compared to ANOME for one factor. In this case, first we check the interaction effect plot. In case any of the factor levels in this plot is outside the decision limit, then the response at that factor level is considered to be dependent on the levels of other factors. Now it's very important to remember that if we find a statistical evidence for a significant interaction effect to be existing, then in that case the main effects plot interpretation will not help much in determining the statistically better factor level. And if there is no significant interaction effect, then in the main effects plot we look for those factor levels which are outside the decision limits, and those factor levels would be considered statistically different from others. I hope this video was useful. We would always be delighted to see your likes, comments and mails as we consider you an integral part of our learning endeavor. Keep watching this page as we plan to host more learning videos on concepts from DMAC, Lean, DFSS, re-engineering, theory of constraints, BPM and operations research. Please do subscribe to the page and keep receiving updates as and when we upload a new tutorial. Do share the links or channel details in your group so we end up creating a much larger learning community. In case you want us to talk about any specific concept, feel free to contact us. The contact details are mentioned here on the slide as well as on the page. So good luck and happy learning.